All right, hi guys. I just wanted to do a couple of examples for you because we missed class on Wednesday and the homework's still due Monday. We kind of need to keep moving forward. I mean, we're going pretty fast, but I do a couple examples for you. I've had some questions on the homework on 6-2 because some of these application problems can be a bit tough. So I'm going to do two examples. You know, hopefully it'll help you. Help you in your homework. And then I'll answer any questions that you have on Monday. So my first example, again, these are applications, right? Right triangle applications. So the first thing we have is we have a steel cable, real life here, people, zip line. I love zip lining. Zip line is being constructed as shown below. So these kind of take a bunch of setup, but okay, so here's the deal with the zip line. What we're going to have is we're going to have a 5-foot, let me undo that, hold on. We're going to have like a 5-foot pole here. Okay, so this guy here is going to be 5 feet. Okay, and then the zip line is going to attach to the top of this pole at an angle of elevation of 23 degrees. So I'll have this zip line, you know, it's coming up at an angle of elevation of 23 degrees, and then of course it's attached to the top somewhere. My lines are so beautiful in this program as opposed to on the board when I do this on the board. And then of course here is the ground, right, that the zip line is on. Okay, so the question here is, I have a couple questions. How long is the zip line and how far is the stake from the pole? So, let's undo that. Spending way too much time on this picture. It doesn't really matter. So this is the pole, okay, that the zip line is. Maybe you're on the zip line and you start going down it, and then this is the stake that we're at. And then what we also know is we know that there's an angle of elevation from the stake, okay? So angle of elevation from the stake to the top of the pole is 23 degrees. So this guy right here is 23 degrees. And of course, we're living in perfect math world, right, where the ground is perfectly flat and everything makes a perfect right angle with everything else. It's just a lovely world to live in. All right, so first thing I want to ask is how long is the zip line? Oh, I need to tell you one other thing. I bet you're asking this as well. I know how tall the pole is. The pole is 150 feet. We kind of need that. Okay, so the pole is 150 feet. We want to know how long is the zip line. So our unknown here is going to be the length of this zip line right here. We could just call it C if we wanted to. And I need to figure out some sort of formula for doing this. So I think you can probably see what's going to happen here. I'm just going to kind of extend my horizontal across and kind of look at that being a right triangle if I extend that across. And this is the right triangle I want to use, correct? Because I have this 23 degrees. So the question then is, what is the length of this side right here? Well, this is clearly not to scale because this distance right here is 5 feet. This whole thing is 150 feet. So I know that this distance right here, again, not to scale, is going to be 145 feet. So to find this out, we'll just use a little bit of sine. Or we could use actually cosecant, but we'll just use sine of 23 degrees equals 145 feet over C. Okay? And I hope that makes sense why it's 145. We have to subtract out that stake, the length of the stake there. So what I'm going to do to solve this is I'm going to multiply both sides by C, okay, to get rid of the fraction, and then I'm going to divide both sides by the sine of 23. So what we end up getting, these guys cancel, and if I divide by sine of 23, I get 145 divided by the sine of 23 degrees, which, in my calculator, I have not done this yet. I've not had enough coffee this morning yet either, so we'll see what we have here. We have 371.099 or maybe 0.1 feet. And on these word problems, I'll probably have you answer in a sentence. So we would just say something like the zip line is 371 feet. Okay, good. good. And then the other question I wanted to ask on this one, we'll try and fit on the same page. How far is the stake from the pole? So what is the, this is asking basically what is the horizontal distance that I would travel if I were on the zip line. So here again, all we're just asking now is we're asking for this distance right here, because it's going to be the same whether it's 5 feet in the air or on the ground. So I don't know, we could call that B maybe, and clearly then well, we know C, we could use C, but C has been rounded, so I actually would prefer to use this 145. So that actually tells me then that the tangent of 23 degrees equals 145 over B. Multiply both sides by B and divide by the tangent of 23, and we get B equals 145 divided by the tangent of 23 degrees. And if we do that, we get 341.59. So B equals 341.59, which kind of makes sense, well, 6 if we round it, because that distance should be a little bit smaller than the zip line, but should be, pretty close to the same amount. But that zip line's traveling a little bit further because it's 150. It starts 150 feet in the air. So I hope that makes sense. The other example I would like to do, and you do have one of these on your homework. It's going to be kind of a long writing one. So let's write this out real quick. So in traveling across flat land, of course, okay, you notice a mountain, as happens around here. You notice a mountain in front of you. So it's in front of you with angle of elevation. Because really, who doesn't drive around with a protractor in your car? So of course you're going to stop and figure out the angle of elevation to the mountain that is in front of you. Anyway, traveling across flat land, you notice a mountain in front of you with angle of elevation 35 degrees. After driving 13 miles closer, so you're driving toward the mountain, which is kind of important, and I'll let you know why. You find that the angle of elevation. Angle of elevation, and I already see a mistake I've made. Whoa, and I can't write. Elevation is 9 degrees. This is not 35. This is 3.5. Sorry about that. Which would make more sense, right? Because if it's 35-degree angle of elevation, that's pretty high, and then if we're getting closer, it should increase because we're getting closer to it. Sorry, 3.5. After driving 13 miles closer, the angle of elevation is 9 degrees. Approximate the height of the mountain. Okay, so all right, so let's draw a picture, right? That's going to be the easiest thing. So, of course, we are on flat land, right? So here's my flat land. And the big thing about this is, and let me draw my mountain. Here's my mountain. Whoops. Here's my mountain. I hope you like it. Okay. And then, of course, I'm going to think about, well, if I care about the height of this mountain, this is what I really care about, that pink line right there. And so we're going to build some triangles, right? So what am I going to look at? Maybe I shouldn't have made the mountain so triangular, but at some point right here, I notice that my angle of elevation, right, up to the top of the mountain right here is 9 degrees. So, or excuse me, 3.5 degrees. So here's my 3.5 degrees angle of elevation. And then what do I know? I know after driving 13 miles closer, so I'm going to get closer to So after 13 miles, maybe I'm right here. And I take the angle of elevation again. And I find that my angle of elevation is 9 degrees. Okay, and what else do I know? I know that this distance right here is 13 miles. Okay, and what do I not know? I want to know what is the height of my mountain. Or I could have used Y maybe, but I just will use H for right now. So if you look at this, I'm going to erase this part of the mountain really quick. You get the idea that it's there, because I want you to see that we really get two triangles. Okay, so I have two triangles then, and I have a right angle, of course, because I want to look at the height of the mountain. Now if I want to know H, here's the problem. Sorry, I had to pause for a drink of coffee. I mean, ideally, right, I would know in this little triangle here with the 9 degrees, I would know one of these sides. Well, I don't. Or ideally, if I had this big triangle with a 3.5, I would know one of these sides, and I don't. All I know is that this is 13 miles right here. So what I'm going to do, this is going to be fun. You guys are going to really, really like this. I like that I'm lecturing to myself, and I just am imagining that you're going to really, really like this. So what I'm going to do here is I'm going to label this side right here X, because if I can find X, or if I can somehow relate X and H together, I might be able to find H. Okay, so I'm going to look at my two triangles that I have, and I'm going to write out some relationships between, you know, the two big triangles. So let's look at this big triangle that has the 3.5. So that triangle is going to be, this guy right here, right? I know that looks, I'll undo this, don't worry. That's this big triangle right there. Okay, so I'm going to look at a relationship between the angle that I know I have. So that would be the tangent, right, of 3.5. What do I know the tangent of 3.5 degrees would be? Well, it'd be this side, opposite side, right, which is H, divided by this side here. Well, what is that side there? It's not just 13, it's not just X, it's X plus 13. I hope that makes sense. So I take the opposite, again, ignore this guy right here, just think of that big triangle. I'm going to take the opposite, which is H, all over this side, which is X plus H. And then I'm going to do the same thing. So now I'm going to focus on this little triangle here. Okay, and I'm going to focus on finding a relationship there as well. So that one's a little bit easier. That one we see that the tangent of 9 degrees, what is it going to be? Just H over X. So notice what we have. Tangent of 3.5 and tangent of 9, those are just numbers. Okay, so really what I have is I have, just like what we did this in 1400, I have an equation, two equations with two unknowns. So I can solve this for one of the unknowns. And I think the easiest way probably is just to solve this equation right here for H and then plug that value in here. And then we'll actually end up getting X, but that's fine. We can come back and get H somehow. So what I'm going to do here is I'm going to go ahead and solve this equation here for H. So I'm going to multiply both sides by X. So what do I see H is? H is X times the tangent of 9 degrees. If you wanted to, you sure could find the tangent of 9 degrees, but I just don't want to deal with the decimal right now. I'm just not in the mood to deal with the decimal right now. So I'm not going to worry about that for right now. Let's see. So where am I going to put that? So this H right here, I'm going to take this. I'm using substitution, which we used in 1400, right? And I'm going to plug it in for that H right there. And then we'll see how to solve this. So I would get, I'm going to need some room, so I'm going to try and write kind of small. Tangent of 3.5 degrees equals X times the tangent of 9 degrees all over X plus 13. So again, you see this stuff, we did this in 1400. I want to solve for X now. How would I solve for X? Well, what do I want to do? I want to get rid of the fraction, right? So I'm going to multiply this side by X plus 13. I'm going to multiply this side by X plus 13. We did these. Remember when we were finding inverses? We did this. Now if you notice, I have an X on both sides of the equation. So I'm going to take this tangent of 3.5. I'm going to multiply it through to each term. And I'm going to get everything with an X on one side. So I get X tangent of 3.5 plus 13 tangent of 3.5 equals x tangent of 9 degrees. Okay, so look at what I just took that tangent of 3.5 through, and now where are the terms that have the x that I want? These are the two terms, so I'm just going to take this one here and move it over to the right hand side. Oh, this is so fun. I love doing these. All right, so 13 tangent of 3.5 equals x tangent of 9 degrees minus x tangent of 3.5 degrees. And now what do you notice is common to both terms? That's right, it's an x. So I'm running out of room. So I'm just going to factor that x out. What would I be left with? Tangent of 9 degrees minus the tangent of 3.5 degrees. And then finally, what would I do to finish this up is I would just divide by that whole thing. So what do we find x to be? X is going to be this side right here, which is 13 tangent of 3.5 degrees, all divided by this stuff right here. Tangent of 9 degrees minus the tangent of 3.5 degrees. Oh, that's so much fun. So let me put that into my calculator. So 13 times tangent of 3.5 divided by, I am making sure I put parentheses around the entire denominator because I'm dividing by more than one term. I'm dividing by a sum or a... So what do I get x to be? I get it to be, I should have drum roll or music or something playing, although we're not done actually after this. 8.17834. 17834. Okay, so that distance right there. And what are my units on these? Remember, this is miles. Okay, because this is miles. So 8.17834 miles. And now what's my final answer? Well, what I really want to solve for, right, is h. So I just need to plug that in. So I'll do this up here. So h is equal to x, which is 8.17834, times the tangent of 9 degrees. And so what do I get? Let's do that. Times the tangent of 9. Oh, this is very, very, very exciting. H, what's the height of the mountain? It's about 1.295 miles, right? So a little bit more than 5,200 feet, which is a pretty small mountain for us, I guess, around here. And then you could write that in a sentence. But I hope that helps. Do you have one like this? I think there's one like this on your homework where there's like a ship that is a ship that's going toward like a bridge or something like that, where it takes 2 angles of elevation, and you're going to want to do something similar to what we did here for that problem. So I hope this helps. Of course, email me if you have any questions, and of course on Monday we'll go over any questions you have on the homework. I'll also put up the solutions and the fun sheet on Blackboard for 6.2 so you can look at some more examples of how to do this stuff. All right, you guys, have a great weekend. I'll see you on Monday.